Hello everyone, this is Bradley. Recently, I needed to do a shot with a blade trail. When I was thinking about it, I came up with a method to loft the curves, or in other words, connecting curves to construct the polygons. So today's topic is about how to loft the curves in Blender geometry nodes. And in the later half of this tutorial, we are going to use these loft the curve techniques to do the blade trail tutorial as well. I combine these two topics together because making a blade trail is the biggest motivation for me to find out these methods. But I also want to emphasize the technique of loft the curves because it can be used in many other places as well, not just for making this blade trail. And I also hope you can review my journey about figuring out this loft the curves technique and then finish this blade trail animation. So let's start. So here we're in Blender. At first, we're going to discuss or demonstrate what loft the curves does, how to make that, and then we're going to move on about how to use this technique to make our blade trail. And when you're solving your problems, you always want to start with a very simple example. So here, it does not need to be complicated at all. In fact, it must not be complicated. So we start with Bezier curve, and I need to duplicate it about 4 times. Actually, this is more than enough. Okay. Here, I'm going to add a plane to hold the geometry node tree, and I'm going to import this collection of curves together. Right now, it's outputting a single instance. So I'm going to realize instances so that I can access 4 splines inside together. And just to demonstrate what loft the curves does, I'm going to use the preset of loft the curves. Okay. And you can download this preset for free from the link in the description. It will speed up your workflow. But I'm also going to break it down in this tutorial to talk about how to build it. Okay. So basically, the idea of loft the curves is that we're connecting points to points of these curves. Okay, and upon connection, we are making up a polygon. So we basically will have 3 polygons in total in this setup. And this is what we get. And since this is procedural, so you can also duplicate a new curves and it will be connected. This is very important. This can be useful when you are making certain kind of architectures. And it can also be used in motion graphics. A very famous example is an animation done by Victor. And what he does is that he's connecting all these kind of curves together to make up a kind of cup transitions. And this is basically the result after connecting these curves together. So this is like a kind of a screw modifier on a different axis, but it looks kind of very cool. Okay. So this is basically how loft the curves can be used in the industry. Okay, now we know this technique is very powerful, but how can we make up this effect at the first place? If you look at the completed version of this entire effect, you realize that when we're connecting point to point to form a polygon, the final product essentially is just a plane, a subdivided plane. So you can make up another plane and you just move that and you subdivide 3 times in the middle. Then you realize these two are basically identical to each other. Okay, so doesn't that mean that I can potentially just map our vertices to these curve points 1 to 1, and then I will have basically an identical result. So in this case, we can use our sample index node to map our position attribute with the index, okay, for geometry. To make this concept more procedural, we can use the grid node inside the geometry nodes. And in this case, we may just mimic that with the vertices 2 and vertices y5, so that we have basically the identical result. However, since we are sampling the index must match. And if we look at the index of our curves, and we can, in the overlay, turn on this attribute text, you can see this index is going from 0 to 1, 2 to 3 in kind of horizontal direction. And when you're looking at our grid is actually going at a kind of vertical direction. So this means that if we directly use these methods, we will have wrong result and set position. We will have this kind of crossing result, which becomes very chaotic. This is simply because we need to reverse the order so that the index will match each other. Okay, and this is kind of very important. From this example, we can learn that the resolution of our curve should correspond to vertices y. And here I'm going to add a resample curve to make sure all curves are having the same resolution to connect the point to point. Okay, and this count should synchronize with our vertices y. And now we recover our desired geometry, and we also have a value to control the amount of subdivision of it. Okay, you can subdivide more. On the other hand, the other subdivision actually depends on the amount of our splines, and it will correspond to the amount of our vertices x. Otherwise, if I duplicate another curve, then there will not be any connections. So to solve this kind of a problem, we need a domain size node. And we can set that to curve and use the spline count to our vertices x. So now, no matter how you are duplicating your curve, they are always connected. And even if you add a new curve, for example, a NURBS path, due to this resample curve, then they will have enough points to connect to each other. Okay. The good part of this method is that we have a UV map constructed for our grid from the beginning. And this UV map is still valid after being remapped to connect all these kind of curves. Okay, and this can be very helpful when you want to put a texture onto it. And the usage of preset is basically to replace all these kind of 8 nodes. I also added some additional functions to it, but basically this is the concept. Okay, and I think this is pretty easy. It's not complicated at all. In fact, I didn't use any math node yet in this setup. Up to now, we have finished talking about loft curves. But how's that relevant to our blade trail animation? The relationship is actually quite straightforward. So let's go to our armature. I downloaded this slash action from Mixamo and I slowed it down. So you basically have a kind of a slow motion slash effect in this case. And to make up our loft curve animation, we at least need to have two curves, or at least you need to have one curve. So where do we get this curve from? This is quite straightforward. So you just select this kind of blade. And I'm going to hit tab, go into the edit mode. And I select one edge object. Shift D to duplicate that so that I have a separate edge. And hit P to separate selection. So there will be a single edge available. So let's name that as a blade trail reference. Because this is just a single edge, so it will not show up in the render. And we are going to track this edge. Next, we can add a plane to hold a new geometry node tree. I'm going to name that as a blade trail. And to import this blade trail reference to my node tree. So now I can disable my armature collection. And if I hit this relative, then the mesh will be visible in world position. And I'm going to make a copy of this edge every frame using simulation zone by making a join geometry. And now if I play this animation, each edge is basically a copy of the edge on a particular frame. Okay. And right now you may realize, why do I need this loft curves technique? Because I need to connect these curves together to form a surface for my material and a texture. If I drop my loft curve, then it will pop up a warning: input geometry has unsupported type mesh. This is because this is an edge, not a curve. So we can do a mesh to curve simply to fix this issue. You can drop that before or after, but in this case, I'm going to drop it before. You will not see the effect immediately because you need to run this simulation again. Then you will find this surface. Next, we can focus more on the set material side of this effect. We can take a set material node, and I'm going to add a new material called the trail frame. And type in this trail frame. And I also need a UV map for our noise texture. I talked about this node in the past. Essentially, it's just comparable to the store named attribute, but working on the face corner domain for vectors and so on. Okay. It's kind of very simple. And I do not want to work with this moving mesh. So I'm just going to replace that with a curved line node for the moment. As I said, you should always start with a simple example so that you can focus on something better. But now if you play this animation, you can see there is no visible mesh being created because this curve line is not moving. So here we're going to move that using a set position node. So just imagine this curve line is actually the resting position of your blade. If you are not rigging your character with kind of a breathing moment, then this blade will just not move, and you want the flame to actually go up. So we're going to simulate this inside geometry nodes with delta time on the z-axis. I also talked about the delta time in the past. And in this case, now you can see this is the effect we are seeing. Okay. There are two kinds of problem. One is that this is going too slow. I'm going to add a multiplier to this delta time. You can add 5. The second issue is that there are too many splines and it will go infinite. So I'm going to delete based on their age. Here I'm going to store a name attribute, and this attribute will be the same time frame. And you can call that whatever you want, but I'm just going to type a t. This is going to be the birth date of your particle or your spline. And this frame is the current time. The current time to subtract your birth date means you're having an age for your particles. So right now we can do two things. One is to delete this spline based on the age. So if the spline age is greater than maybe 15, then it will be deleted. So this is the effect, okay? And the second issue, one more thing that you can do is you see this, the trace should stay on the ground, but it's elevated because of our set position. So we're going to select that. So we only move this spline if it's 1 year old. So now you can see this is kind of very important because we keep this spline at its resting position, and then this edge will be better fit to our moving character, the spline we generated. As you can see, this point, yeah, right, this point, yes, that's it. Okay. Right now we have really prepared everything as far as I can see. So let's just go to our material shader, and we can play this animation. We can go to material preview. You can see the color is changing with it. Here I'm going to add the UV map, and we can see this is going from 0 to 1, 0 to 1 on each of the axes. It might be better if we use a separate XYZ to visualize this effect. Okay. Sometimes the order may be opposite. It's something that you have to fix by yourself. But anyway, okay. Just to get a very quick effect, I'm just going to use the noise texture. I talked about this kind of flame texture in the past, but I'm going to repeat this again. So let's take a vector mass, and we basically just animate that. Let's take a color ramp so that we can have more contrast to this effect. Okay. And then we can have multiply on different axes to have different effects. We can animate this effect by animate this addition of mass. And we're going to put some mask to fade out these different sides of my flame texture. So for y-axis, I'm just going to take a color ramp. In fact, I have a value interpolate node, which will do a kind of mirroring. So how is that being done? It's essentially just to have a white in the middle and a black on the side. Okay, you see there are many clicks with that. That's why I like to use these presets. I just click, then I have a mirror effect. Simple and easy. So now we multiply that. Mass multiply. And then we can take a color ramp. Okay. Something like that. And we also need to fade out the top parts, which is doing with this x-axis. So we need another multiply. And having our x-axis to connect that with it. And then we take another color ramp. You see this is kind of tedious, but this is true. This is how this thing works. Okay. And then we are going to take an alpha. So I have a preset called emissive alpha BSDF. This is essentially just a mixed shader with the emission shader and the transparent shader. So you can see the color, you can see the strength, you can see the factor. They are corresponding to each other. And here I'm just going to put that into the alpha. And it's very noisy because eevee Next is using the dithering by default. You can change that to blended. And it will be less noisy. So you can also take a color ramp to set the color of our emission. We need a white color, we need a yellow color, we need an orange color, I need a red color. Okay, so now we have all this kind of effect. You can turn on the balloon. Make sure to turn on this compositor always, and in the compositing option, you should have a glare node attached to the compositor. So by increasing this emission, you should see the bloom. There will be kind of issue that you may not be aware. This is the color management transform. AGX is a very nice view transform, but it has a downside that the brighter it will be, less saturation will it have. So it's not suitable for stylized, in my opinion. You want to change that to standard. So now you can see the yellow color very nicely. If you want to have white, you just add white. Where's my white? Okay. Yeah, something like that. Let's turn down this light. And yes, basically this is that. And you can animate this entire combine XYZ with a time info. And you can turn this speed. So basically this is it. Up to now, this is basically what I can show you for this entire blade trail animation. Okay, I hope this is not a very overwhelming setup because these are all the nodes you need. There are definitely other customization that you can do, which makes the node tree complicated. For example, take a set position node, and I have a noise 3D to displace that with a noise texture. And you want to keep the baseline stable. So you basically use the same technique as a separate XYZ for UV map. You realize the black-white is switched. So we reverse that using remap 0 to 1. And the result into the fall, the baseline is stable no matter how you increase the scale. And you can add a time info node to animate either the position or the evolution. And now if you play this animation, you can see this kind of wiggle. But you also find that there are some jagginess of this entire texture. This is simply because we do not have enough amount of subdivision, which distort the UV map a little bit. And we can solve that with a subdivision surface. Okay, then it smooths out everything. There are other things that you can do. For example, you take a fill volume node. It's not a real volume, but it's stacking the planes to give you a sense or illusion of a volume. You can hide that by increasing the count. Then you will find there are kind of thickness when you're looking at the other angle instead of just a plain kind of stuff. And you can also increase different speed or differences. For example, index to seed, then you have different layers of it. Okay, this is also kind of fun. You can try to tweak all these kind of vector parameters as you wish and decrease it. It looks kind of very weird, but it's something that you can always change. And then you can also tweak that from the noise side as well. We can increase the W, white noise, just the SD gradient, the W, and we can use this W in the noise texture. Remap 0 to 1 or not to increase the differences. There are so many things that you can potentially do with this setup. But basically these are it. Okay. And right now we can switch back to our armature animation. And if you look at our armature and its blade, you can see our flame is nicely attaching to the entire blade. And that's it. There are so many other things you can do. For example, just multiply different values. This is also fun, but I don't think this is good. You can try with so many things, not just the one method, but multiple other things for the texture. But I think this tutorial has been long, so I will just finish it here. I hope you enjoyed this video. I'll probably see you next time. Bye bye.